Welcome, everyone. Welcome to today's webinar. Today we're going to be talking about an introduction to SOLIDWORKS Electrical. My name is Mark Talbott, and I'll be your presenter today. Essentially, I'm the electrical specialist at Fisher Unitech. What that means is when it comes to demonstration, a little bit of support, training, just any questions that you may have, I'm one of the individuals that will assist you in those matters. I've got a host of education and degrees and field experience in the electrical products as well as their electrical certifications. So really that just means that I'm here to service you in these areas. So our agenda today is we're going to start off talking about the benefits of using a collaborative platform. Then we're going to look at the electrical schematic tool and see a demonstration of that as well. And then we'll jump into SOLIDWORKS Electrical 3D and the benefits and demonstrations for that. At the end, we're going to end with a Q&A, so feel free to ask any questions you have throughout this presentation, and that can be just thrown into the chat, and then we'll go through those at the end. So why am I starting with collaboration? Well, essentially, in today's marketplace, with the divide between electrical and mechanical environments specifically, there's a very serial workflow. Maybe you're restricted to one guy who has to work on one project for electrical, and then when that's done, it moves over to the mechanical. Then they have to look at a bill of material, or they're looking at your schematics, and they're actually populating those components. And really, there's some inefficiencies with this. If you're working in parallel, you can place the components in either environment, and that information will intelligently be usable in either environment. So that's where you can move to with a parallel workflow. Ultimately, anytime you have better communication, that tends to mean fewer errors and faster time to market. So with a collaborative tool, you have a stream for that communication. And you're also able to document changes better in a collaborative platform. When it comes to response control, resource management, having a collaborative platform, if you have a time-sensitive project that's come up, you can put all hands on deck if that platform is collaborative. And ultimately, this is where industry has moved. So if you wanted to stay relevant in today's market, in today's design market, and if time to market is important to you, then collaboration is going to be important to you. So all that being said, the question is, okay, well, what collaboration is available with SOLIDWORKS Electrical? Well, the collaboration that's available is both multi-user and multi-software. And so what that means is you can have several electrical designers working on the same project simultaneously, and you can also have the mechanical environment working on the same project simultaneously with those electrical designers. So it's truly a collaboration effort from every side of the coin here. So let's just take a step back and do a brief overview of SOLIDWORKS Electrical. So SOLIDWORKS Electrical is actually divided into kind of two parts here. SOLIDWORKS Electrical Schematic is the first, and SOLIDWORKS Electrical 3D is the second. So the schematic software is actually a standalone software. You don't have to have any other mechanical platform. You don't have to utilize collaboration. It's in its own right able to save you time, reduce your errors, and it's actually a general schematic software, meaning if you're documenting pneumatic, hydraulic, PNID, any other types of schematics, the tool is able to handle that as well. Ultimately, you're placing symbols and you're making connections. Within the tool is built in the capability to do 2D layouts. If you have electrical 3D, which sits on top of your mechanical seat, you're also able to utilize the tool to make those 3D layouts as well. And ultimately, the tool is parametric. So just like SOLIDWORKS is parametric, where if you make changes, it documents through to all the places that need to be updated, the same is true for SOLIDWORKS Electrical. So when it comes to reporting, when it comes to wire numbering, to any changes that you make, you can track those changes, and those changes will intelligently update throughout your design. And ultimately, what I hope to show you is how we can lessen your documentation time compared to your current process, reduce human error in the process, and also invest in a tool that is collaborative in nature between the divides of your company from person to person or electrical to mechanical. So let's take a step back and look at what the common documentation process is today. Well, just about everybody starts with the logical definition, part selection, and essentially when you begin, you just want to see on paper, you want to see what is connected to what components are going to be organized. Well, from there, when it comes to ERP documentation, ordering parts, to manufacturing, that's when the reports need to be handled. Now, what I've noticed today is a lot of companies, maybe similar to yours, they're doing this via Excel. They've got a 2D tool, they open up Excel, they're doing cell-by-cell manipulation, they're creating the schematic and then typing everything out. And then they're really stopping short there. They're not really producing wire cable lists from two lists because of the burden that it takes on their designers. But ultimately, those are the kind of documents that can help push manufacturing and standardize manufacturing and save time on the manufacturing side as well. From there, you have to flow into auditing because you have all that cell-by-cell manipulation, you've got all the schematics, so an auditor has to review all this information. And then if there's any changes, this becomes a cyclical process. Now, I've talked to a lot of customers who, when we talk about auditing their auditing process, they say, you know what, really our auditing process is manufacturing. And some have even said it's the customer. So these are very expensive auditing processes and really hardly even one, because this is where, production gets held up. You're missing parts, mistakes get to the customer. You can see the list goes on and on when it comes to auditing and value. So let's really compare, what does it mean to have a parametric software versus just kind of a 2D documentation tool? Well, essentially, if you're asked to make a change, in this case, we're just going to consider one component. Well, that component, it should be easy enough, quick, simple change. That component has a lot of information that's tied to it. Besides this mark, you have to consider terminal names, wire numbers, any other characteristics that you want to display. And then all that information also carries into the various reports that you may have, into your bill of materials. So you can see where this simple change, this one component, has really affected around 40 aspects of my design. And ultimately, when you take this into auditing, well, the question becomes, will you be able to find any mistakes? Right? If you're typing anything in manually, there's high chance for mistakes, and we're only considering one component right now. So imagine a project with 50, 100 components in it. This just becomes, the risks here become exponential. And in this case, there's actually a mistake on this page, and that mistake was customer facing. It was printed out for the label put inside of a panel. And ultimately, would you honestly think that you'd find this mistake if you were reviewing your project? The other thing I want to mention here is your designer, they've spent a lot of time in education, maybe they have a lot of experience, and so they're very good at the design, and as designing, that's really what's bringing the company value. However, in this case, in this example, our designer has spent maybe 5-10 minutes selecting their part, and from there they've spent maybe 2 hours, maybe plus, documenting that part. And again, this is one component. So ultimately, your value is having that designer sit in the role of designing. And the longer you can have them in that role, the more value it's going to return to the customer, because the more products you're going to get for your customers. So let's look at this documentation process from the perspective of SOLIDWORKS Electrical. When it comes to our schematic documentation, we're able to pull in information right from a library. So that means you don't have to type anything in manually. Anything that you would have typed into a schematic, you can put right into your library so it's available for reuse. Because it's parametric, that means the reporting side of things and even some generated drawings, those are going to be done with the click of a button. That also means that that information is going to be correct. So if you have good information in your library, it's going to be good outputs for your projects. So what this does functionally is it actually reduces the scope of auditing. So now your auditor, your auditing process, instead of having to go through, look at every single cell, make sure everything's typed out correctly, they can focus in on the schematic. So reducing to one aspect of the design. If everything's right in the schematic, everything below is going to follow suit. So how does this work? Well, this works from the SOLIDWORKS Electrical library. So here we have a sample of our manufactured part. This represents one part. Basically, any information you would normally type into any part of your project, you can put in the library. That includes graphical information. So this manufactured part is represented by different symbols throughout the project, including on the 3D side, and those can all be linked to that manufactured part. So as soon as that manufactured part is established, you're in a 2D footprint, for example, you just right-click Insert, and it's going to grab the correct symbol for you and that established symbol for you. In addition, we've talked about the parameters or attributes that are located within that part, and that's going to populate throughout your entire project. So consistency, accuracy, and saving time, all as a derivative of your SOLIDWORKS Electrical library. So with that, let's go ahead and jump into SOLIDWORKS Electrical Schematic. So this is the schematic software. Again, it's standalone. And what I'm doing here is I'm actually going to create a new project from a template. And what this means is I can actually build up a template, build up a project, save that as a template at any stage in the game. So it could be completely filled out, and you can use that as a starting point for data reuse. Next, I want to show you the kind of folder structure. You have a lot of flexibility here. You can attach PDFs, you can attach this to solid models, you can organize your project any way you want. And here's an introduction of the project that we're going to be looking at, this pallet dispenser. We have hierarchy to how we can design. This is a single line diagram. So I'm just going to copy and paste our motor, and we're going to watch this motor document through our entire project. And I want to connect this motor up to our terminal strips. And this wire I've drawn is actually, it's more than just a line. It actually has metadata behind it. And as you can see now that I've double-clicked on that wire, I can see the connection points on either side of that wire, see what's available. And I can go in and reserve a cable with cores and actually connect those cores up right from this view. So right here, we could quickly sketch out our projects, keep our design organized, and ultimately drive those connections at this point that would drive our reporting or even our routing in 3D. So that is our single line diagram. It's not a required part of the design, but for the sake of this workflow, that's why we're taking a look at this. So now I'm on my multi-line schematic. I can do a quick search for our motor symbol that we want to place in here. Or I can create custom views of the symbols that I like to see. And so I've thrown our symbol in a miscellaneous category, and it's simply a drag and drop over the wire style. And then it's going to ask us, okay, what do you want to associate the symbol to? So I'm going to associate that to the M5 motor that we added previously, because that motor already has a manufactured part tied to it. Now that I've done that, you see that all my attribute information has shown up for me automatically because it knows that information from the library. So I just need to draw my terminals, also choose our existing terminal strip, and that information will populate for me as well. Now, these terminals here, I haven't actually yet assigned a manufacturer part, so I'm going to go ahead and do that now. So you can see at the bottom, I've got my 4 terminals I need to add. I can go into our manufacturer parts library and assign those. And what this is going to do for us is now when it comes time to do a 2D layout, it's going to know what 2D symbol I need. Any bill of material information, it's going to know what bill of material information I need. On the 3D side, it's going to grab the correct 3D part just by assigning that manufacturer part to the symbol. The other thing I've done here is I've shown you 2 workflows. You can start with the manufacturer part and grab the symbols from there, or you can start with the symbol and assign the manufacturer part to that symbol. And at this point, what I want to do is I've got my wires here, and those are actually cores for the cable that I added previously. And so I can actually assign those wires to the cores in whatever order that I need to, and it'll bring that information from my single line diagram. So even though that single line diagram wasn't required, in this case, I can use information that I've put into it later on in the project. So next, we want to actually create some terminal strip drawings. Now, in industry today, people are drawing these by hand, or they're not even attempting it, again, because of the time it takes. But I hit Generate Drawings, and as you can see, I now have a terminal strip drawing created from my schematic information. It's all correct, it's automatic, and it's configurable. If you want this in a table view, you can get this to look however you want. And ultimately, this is going to help your manufacturing process, your manufacturer. Instead of him going through 100 schematics and writing down all the terminals, you can provide that information to him in one cohesive kind of explained drawing there. So the next question is, okay, what if I have data reuse? I always connect these motors to a PLC, so I've got a transformer circuit here. Well, I'm going to use that in several projects. You can actually library that information and collect it and save it into your database for reuse from others. And this can be done at any level. So any number of symbols and wires that are commonly used, you can save off as their own entity in a library, and that's available for reuse. This can actually go into the schematic level as well. So in this case, I have one schematic. I can go ahead and insert a PLC, for example, and maybe it's the same every time. So I can save that PLC as a series of schematics, and all the circuits that are associated to them will be inserted. And so that's what I've done here. I've just inserted those 3 schematics representing my PLC. You can see all the circuit information is applied. So at this point, all we need to do is connect our transformer to our PLCs, and that is done with the Origin Destination Manager. This is just a way to toggle between several schematics at a time. And I can select a wire style, and it will restrict me to only being able to connect it to the same wire style available. The other nice thing about this is this information is hyperlinked. So I can double click, and it will help me navigate through that project. If this was a PDF that I printed, that hyperlink still exists. So you can imagine where this can really help you navigate in the shop floor even through a project as needed. So from here, we've talked about a PLC that we reuse all the same. It's all the same every time we reuse it. Well, what if you want to configure your PLC? Well, instead of drawing your symbols and placing all those symbols, you can get a table view of your PLC, and you can actually assign circuits to each pin. And what this allows you to do is, again, hit the Generate Drawings button. It'll actually draw, based on that table information, your entire PLC and those circuits that are applied. So you can actually configure your PLCs. So another good tool for time savings. Again, today this is done. You have to draw your PLC, you create several symbols for your PLC, you have to add every individual circuit and all the mark information. This is done with the hit of a button, just from a table view. So from there, let's go ahead and look at our panel drawing. Now this drawing, it actually gives you all the parts in that location of that panel. And I can select all the parts I want to insert. I can hide everything that's already inserted. And it's going to grab those 2D footprints, and I can specify a spacing. So just like that, I can quickly fill out my panel and actually optimize my wire numbering based on position in my panel that I've laid out. And so with that, let's go ahead and run our process for numbering our wires. Every wire style we have has a formula assigned to it. And what that means is that those wires, that formula process can be run. And that's going to aid in our reporting process. So right now I'm going to go ahead and generate some reports beyond just our bill of materials. And what's nice here is these reports, they're going to be correct based on our schematic information. If I make any changes, that's going to show up in these reports as well. Now you'll notice in these first 2 reports I look at, we actually have length applied. And that's going to come into play when we jump into 3D and actually route these wires. That length information is going to feed back for us. So next, I just want to end. Here is a drawing that was actually published from the 3D environment. And so that's going to be our motivation for our next section, is how do we edit and redefine and complete this drawing from 3D and post that into this project. So just a quick overview of what we've seen. Because we have a parametric schematic tool, we can save that time when it comes to information we need to generate, having correct bill of materials, saving our time for symbol placement, and you no longer have to type out anything. It's all going to be in a library, and so that information is going to be available for reuse as needed. So with that, let's go ahead and address SOLIDWORKS Electrical 3D. So SOLIDWORKS Electrical 3D sits on top of an existing mechanical seat, and what that means is you are now able to connect all that schematic parametric information to your mechanical environment. So no more do you have to complete your schematics, give a schematic or a bill of material to your mechanical individual. He has to go through all of his folder structures to find all the parts and place them. That's all going to be handled for you. It's going to hand the proper parts to the mechanical side, so now he can route that information. And so ultimately, you now have one unified bill of material if you want. So you don't have to worry about parts getting dropped from one environment to the next or double ordered. You have one bill of material, everything's documented in one environment if needed. And ultimately, that's going to allow you to route everything automatically and really get that realistic physical representation of that project. So put it a little differently, today your mechanical designer will have something that looks like this. He'll have the chassis information, but when it comes to really completing the project, you've already documented all this on the schematic side. So why should he spend time redocumenting that information? Why not use the information that you already have so that when it comes to producing your final project, your final renderings, your documentation for manufacturer or for the customer, that's going to be helpful and done for you. And ultimately, you can, with tools like SOLIDWORKS Visualize, you can really render this information out, get those realistic lengths, and have this imagery even before a product is ever made. So with that, let's take a look at SOLIDWORKS Electrical 3D. So this is SOLIDWORKS Mechanical. Within Mechanical, I have enabled the Electrical 3D add-in, and we can open right from the Mechanical tool our project that we've worked on the schematic side. So both tools are linking to the same database, and what that means is I can actually view the same project structure and make changes to it as needed as well. I can also preview any of the schematics. We had a meeting, we needed to add a motor. Now I've confirmed, hey, it's been added on the electrical side. I already added it on the mechanical side. The other thing you can do is you can open your linked assemblies to that project right from the electrical 3D window. So this is the representation of that portion of the project. We can see that I've already added my motor. Now I just need to associate that motor to the schematic. So there's two workflows here. You can actually work in parallel, both document the same information and tie it together, or you can let electrical hand you the 3D models to be used, and that's what I'm going to do with this panel. So this panel, I'm going to go into that component location, and by the way, this component tree on the left is the same component tree that's seen from the electrical schematic. So any components I add there will show up on the schematic side, and any components the schematics user adds will show up on the mechanical side. So I can grab all the components I want. I can go ahead and insert these. And my smart mates are applied to these components, so it's going to snap to my rail. And I can also specify the distance between, the mate distance that I want between my components as well. And so it's actually pulling these 3D models from the library because they're specified in a specific location on the schematic side. And I've got one mating degree of freedom left here, so it really helps to populate those panels very quickly and organize this project. So the nice thing here is I've got a schematic. I know what everything's connected to. I've got all my components, and they have routing points assigned. So what that means is I can actually auto-route my panel. And these routes, it's actually taking that wire information from the wire styles in the schematic. It's looking at the color, the diameter, and violations of bend radius. And it's actually auto-routing the panel just from a sketch behind the scenes. So I can quickly block out a sketch, and it'll spline along that sketch. You can see we get a really nice realistic length and view of our panel. And we can really tell if we've got a filled out panel or we do very tight panels, you can get another layer of information to whether that panel is going to fit or work. The same thing can be applied for our cables. What's nice with our cables is you can actually specify a point at which the cable needs to break out into its individual cores. So ultimately, if length is a function or a matter for you, if you need to know duct ratio, this is information that's going to feed back automatically into reporting. And you can see how our cables split for us automatically at our points that we've defined. So from here, let's go ahead and take a look at our reports that are in our project. You see we still have a length of 0, but right from the mechanical environment, you can actually control a lot of the processes that are defining your project. So in this case, I'm going to rerun our reports so that we have that updated length information. So already from here in the preview, you can see that we've got those lengths applied. And now that I hit generate drawings, if I go back to that report and preview that drawing, you'll see now we have those lengths because it's been documented and routed in 3D. So from here, next step, well, let's go ahead and create our 2D drawing. Because we have our information in SOLIDWORKS, we can use all of SOLIDWORKS features, and one of those is the ability to create nice automated 2D drawings. So I get my bill of materials, I get my auto ballooning, and now I can save this and post it into my project, into my electrical project. And that's where the template is actually going to be applied to this drawing. So I've gone ahead, I've saved that, I've posted it, and now we looked at this drawing before. We have now updated this drawing with our new panel, auto balloons, auto bill of material, and it's completely filled out. Now, of course, we can create configurations and remove wires and so on. The idea here is now you can have your entire project documented from one space. If tight fit of your panel is important to you, you can take that documentation to the next level. If you are using Composer, or you want to use Composer to document manufacturing, or you want to standardize the look of your panel from designer or layout to layout individual, or even maybe you have multiple companies who are manufacturing your panels, right? This is a good way of standardizing that. We even have customers who are pre-cutting their wires. They're saving on material, and they're helping control the same look for all their panels. So these are all tools, these are all things benefits that you can realize as a result of SOLIDWORKS Electrical 3D. So let's go ahead and take this collaboration full circle. How far can you go with collaboration? Well, we've talked about having your whole project documented from both environments, but you can go a step further and actually utilize PDM, our file data management system, and that can be realized from the electrical environment as well. So when it comes to data cards for your file types, storage of files, management of bill of material tools, you can actually bring both environments under one workflow if that's important to you. When it comes to replicating information from multiple sites or sharing information to multiple sites, linking to your ERPs or whatever systems that you have available, ultimately these are things that you can utilize with SOLIDWORKS Electrical and the mechanical environment. I hope you can see in what ways we can really save that time and reduce our errors in our documentation with the parametric design tool like SOLIDWORKS Electrical. And ultimately, in this case, we've gone over how our schematics can help save that time. We've gone over the 2D and 3D layouts, our automated reporting, reducing those errors and generating those reports, and embracing that collaborative design from both your electrical to electrical designers to your electrical to your mechanical design. And ultimately, you'd be investing into the SOLIDWORKS ecosystem. The nice thing is, once you have your electrical design documented in SOLIDWORKS, you can use the tools that are available in SOLIDWORKS. We talked about 2D drawings, Composer, Visualize. If you wanted to do simulation, like if you want to know a component, how much it heats up, we've got tools like SimFlow. And you're also investing in us and our ability to assist you as Fisher Unitech. We're able to provide training on these products. We can do implementation, consulting services. If you want a turnkey solution where you're off dropping in symbols on day one, we'll build out that information for you. So we're happy to look at your project from that vantage point as well. So now I've just really scratched the surface here on SOLIDWORKS Electrical, so I wanted to include some of my contact information. Feel free to reach out to me or your sales rep if you have any questions. We also have dedicated support for these products as well, and our support line, that's support@fisherunitech.com. And with that, I hope you've enjoyed this, and I want to thank you for your attendance, and this concludes the presentation portion of our webcast.